The Blue Ring Pathfinder is an advanced orbital transfer vehicle created to transform the way we operate in space by offering a wide range of in-orbit services. Acting as a highly capable space tug, it has the ability to move satellites from one orbit to another with precision, whether that means taking them from their initial deployment orbit to a higher geostationary orbit or shifting them into specialized operational positions. This function is becoming increasingly important as the number of satellites in orbit continues to grow, ensuring that valuable assets reach their intended destinations efficiently while maximizing the effectiveness of launch missions. But the Pathfinder's role goes far beyond simply transporting satellites. It has been engineered to perform complex orbital maneuvers such as rendezvous and docking, which open the door to a host of new mission possibilities. These include on-orbit refueling to extend the life of satellites, in-space repairs and servicing to restore or upgrade existing hardware, and even active debris removal, an increasingly urgent task as Earth's orbits become more congested with defunct spacecraft and fragments. What makes the Blue Ring Pathfinder especially versatile is its modular design. Its systems can be customized and configured to meet the unique requirements of each mission, giving it the flexibility to serve both commercial operators looking to protect their investments and government agencies pursuing advanced space programs. By offering this level of adaptability, the Pathfinder represents not just a single spacecraft, but an entire toolkit for maintaining and enhancing the space environment. Ultimately, this vehicle is more than just a tug. It's a multi-purpose workhorse designed to keep space sustainable, efficient, and accessible for the future of exploration and industry beyond Earth. Would you like me to make this script flow more like a documentary-style narration or keep it technical and informative? In the far future, space travel could evolve into something that completely transforms humanity's relationship with the cosmos. Instead of being limited to the boundaries of our solar system, advanced technologies may allow us to journey across interstellar space, reaching distant stars that today feel unimaginably far away. One possibility is the development of warp drives, engines that could manipulate space-time itself to bring distant destinations within reach. Another is nuclear fusion propulsion, capable of producing vast amounts of energy with unmatched efficiency, allowing spacecraft to achieve speeds far beyond what is possible today. These missions wouldn't just involve robotic probes, but eventually human explorers traveling to new star systems. Such journeys would require spacecraft that act as self-sustaining habitats, equipped with closed-loop life support systems to recycle air, water, and resources. Some vessels might even be designed as generation ships, where entire communities live and thrive during voyages lasting decades or even centuries. Along the way, artificial habitats could simulate Earth-like environments, ensuring both survival and a sense of normalcy for the crews venturing into the unknown. The motivations behind such bold endeavors would be as profound as the journeys themselves, expanding our knowledge of the universe, searching for habitable exoplanets that could serve as new homes, and ultimately securing the survival of humanity by spreading beyond Earth. Achieving this would mark a pivotal moment in our history, transforming us from a planetary species into a truly multi-stellar civilization. What once seemed like the realm of science fiction could become an awe-inspiring reality, forever redefining our place among the stars. Would you like me to make this version flow like a documentary narration, calm and inspiring, or like a cinematic trailer, epic and dramatic? Solar sail propulsion is one of the most fascinating advancements in modern space exploration, offering a completely new way to travel through the cosmos. Unlike conventional rockets that depend on massive amounts of fuel, this technology relies on the power of light itself. A spacecraft designed with this system carries a giant, ultra-thin, reflective sail that unfolds in the vacuum of space. When sunlight or even directed laser beams strike the surface of the sail, the photons, tiny particles of light, bounce off and transfer momentum to the spacecraft. Each push is incredibly small, almost imperceptible compared to the explosive thrust of chemical rockets, but the effect is constant and continuous. Over days, months, and years, this steady pressure builds into remarkable speeds that rockets cannot sustain for long-duration missions. What makes solar sails so revolutionary is their efficiency and endurance. They require no propellant on board, making them much lighter and capable of operating indefinitely as long as they remain in the path of light. This means a spacecraft could, in theory, continue accelerating for years without ever stopping. The potential applications are astounding. Scientists envision using solar sails to send probes far beyond our solar system, reaching nearby stars in just a few decades, instead of the centuries traditional propulsion would demand. By turning sunlight into a natural engine, solar sails could unlock interstellar travel, opening the door to exploring new frontiers. It's a vision of humanity literally sailing across the universe, guided not by wind or fuel, but by the timeless pressure of light itself. Would you like me to extend this into an even slower-paced cinematic script that naturally runs longer than a minute when read aloud? NASA's X-59, officially known as the Quiet Supersonic Technology Aircraft, or QUEST, is a groundbreaking experimental jet designed to redefine the future of supersonic air travel. Built in collaboration with Lockheed Martin, the goal of this project is to eliminate one of the biggest barriers to high-speed flight over land, the disruptive sonic boom. Normally, when an aircraft exceeds the speed of sound, it generates shockwaves that merge into a thunderous boom, disturbing people and structures on the ground. The X-59, however, is engineered to reshape these shockwaves, reducing them to a much gentler sound, often described as a soft thump, making supersonic travel far more practical and socially acceptable. The aircraft's striking design plays a crucial role in achieving this breakthrough. With its elongated, needle-like nose stretching almost a third of the jet's 94-foot length and a top-mounted engine that helps minimize shockwave interference, every aspect of the X-59 has been optimized for quiet supersonic performance. Unlike conventional aircraft, the X-59 does not feature a traditional cockpit window. Instead, it uses a cutting-edge external vision system, where high-resolution cameras project real-time imagery onto large cockpit displays that giving pilots a clear and accurate forward view while maintaining the aerodynamic profile needed for noise reduction. Powered by a General Electric F414 GE100 engine, the same type used in advanced fighter jets, the X-59 will be able to cruise at Mach 1.42, about 1,100 miles per hour, while flying at an altitude of 55,000 feet. Its first flight tests are expected to begin in 2025, followed by community overflights across select regions to collect data on how people perceive the reduced sonic thump. The results of these tests will be shared with global regulators, with the hope of shaping new policies that could eventually lift bans on supersonic flight over land. If successful, the X-59 could pave the way for a new generation of commercial aircraft capable of cutting travel times dramatically, allowing passengers to cross countries and even continents in half the time, all while maintaining peace and quiet for those on the ground. Would you like me to make this script slightly longer for a 90-100-second narration, or keep it around a tight 60 to 70 seconds? Polaris Dawn marked a historic milestone as the very first mission of SpaceX's ambitious Polaris program, pushing the boundaries of what private spaceflight can achieve. Launched on September 10, 2024, aboard a Falcon 9 rocket, the Crew Dragon Resilience carried a crew of 4 pioneers: Jared Isaacman, Scott Petit, Sarah Gillis, and Anna Menon. Their journey took them to an altitude of approximately 1,400 kilometers, the highest Earth orbit reached by humans since the Apollo era, placing them well within the Van Allen radiation belts. Over the course of 5 days, the crew undertook nearly 40 scientific experiments aimed at advancing our understanding of life and health in space. These included detailed studies on radiation exposure, the biological effects of extended microgravity, and decompression risks that astronauts may face on future deep space missions. Perhaps the most groundbreaking moment came when Jared Isaacman and Sarah Gillis stepped outside the spacecraft to conduct the first ever private spacewalk. Outfitted in SpaceX's newly designed EVA suits, prototypes that may one day protect astronauts on the Moon or Mars, this achievement showcased how commercial missions can contribute directly to humanity's interplanetary future. In addition to science and exploration, the crew tested SpaceX's high-speed laser-based Starlink communication system, demonstrating the potential for robust, real-time data transfer between spacecraft and Earth. After completing their mission objectives, Resilience returned safely, splashing down in the Gulf of Mexico. Polaris Dawn not only set records but also proved that private spaceflight can achieve feats once thought possible only through government programs, signaling a new era where commercial missions will play a leading role in the exploration of space. Do you want me to make this script sound more inspirational and cinematic, like a documentary narration, or keep it in a clear, factual storytelling style? Rocket Lab has introduced an ambitious and streamlined vision for the Mars sample return mission, offering an approach that could reshape how humanity brings pieces of the red planet back to Earth. Rather than following the current highly complex and expensive plan developed by NASA and ESA, Rocket Lab proposes a faster and more cost-effective alternative. Their design leans on the company's vertically integrated capabilities, which allow them to develop nearly every component of the mission in-house. This includes a dedicated Mars telecommunications orbiter to ensure continuous communication, an Earth return orbiter to safely bring the samples back, and a Mars entry, descent, and landing system equipped with a sample retrieval lander and ascent vehicle. The brilliance of Rocket Lab's proposal lies in its focus on simplicity and proven technology. By streamlining the architecture and avoiding unnecessary complications, the company believes it can dramatically cut the mission's total cost to under $4 billion, a fraction of current projections. Even more impressive, Rocket Lab estimates that samples could be returned to Earth by 2031, years ahead of the current NASA-ESA timeline. This acceleration could provide scientists with access to pristine Martian material far sooner than expected, unlocking new insights into the planet's geology, climate history, and even the possibility of past microbial life. If successful, this approach would not only mark a milestone in planetary science, but also prove that private companies can step into roles once thought possible only for large government programs. It represents a potential turning point where innovative commercial solutions help humanity reach ambitious interplanetary goals faster, smarter, and at a lower cost. Do you want me to make this script more cinematic for narration or keep it in a straightforward documentary style? The Rockwell C-11057, often referred to as the breadbox shuttle, was one of the more unusual and imaginative concepts to emerge during the early 1970s as NASA explored designs for a reusable space shuttle. Developed by North American Rockwell, the idea sought to create a shorter orbiter without reducing the amount of payload it could carry. To achieve this, engineer Harry Scott proposed a radical reconfiguration, rotating the cargo bay sideways. This approach gave the shuttle a compact, box-like appearance, which earned it the nickname Breadbox. On paper, the design had aerodynamic potential, but in practice, it posed significant integration challenges. The unconventional proportions made it difficult to properly align the shuttle with the external fuel tank and solid rocket boosters, key components required for launch. These engineering hurdles, combined with the risks of untested aerodynamics, meant that the concept was never able to move past Phase B studies. It remained a paper design and was never constructed or flown. Despite its cancellation, the Rockwell C-1057 has held a lasting place in aerospace history. It represents the kind of outside-the-box thinking that characterized much of the early shuttle program development, where engineers explored bold and sometimes eccentric ideas in the pursuit of efficiency and innovation. Today, it stands as a fascinating what-if moment in spaceflight design, an example of how daring concepts, even if never realized, can capture the imagination of engineers and space enthusiasts alike. Would you like me to make this slightly longer with more technical detail, or keep it story-like and engaging for narration? SpaceX Starship is more than just a rocket. it's a bold step toward reshaping the future of human space exploration. Designed as a fully reusable next-generation spacecraft, Starship aims to drastically reduce the cost of space travel while opening the door to large-scale missions not only to the Moon, but also to Mars and potentially even deeper into the solar system. When paired with its massive super heavy booster, the vehicle stands at an incredible height of about 120 meters, making it the tallest and most powerful rocket humanity has ever constructed. What truly sets Starship apart is its unmatched capability. With an astonishing 16.7 million pounds of thrust at liftoff, it is engineered to transport up to 150 tons of cargo, or around 100 passengers in one mission. This immense capacity is what makes it central to future plans for interplanetary colonization, where entire crews, habitats, and supplies could be delivered in fewer flights than ever before. Built from stainless steel, the spacecraft combines durability with efficiency, and its body is equipped with heat shield tiles to withstand the extreme temperatures of atmospheric re-entry. Powering this technological giant are SpaceX's advanced Raptor engines, fueled by liquid methane and liquid oxygen. These propellants are not only efficient, but also a key part of long-term exploration strategy, as both could potentially be manufactured on Mars itself, allowing Starship to refuel on another planet and make return journeys possible. By combining reusability, immense carrying capacity, and forward-thinking engineering, SpaceX Starship represents a vision of space travel where humanity is no longer confined to Earth, but becomes a truly multiplanetary species. Would you like me to make this version more cinematic and dramatic, as if it were written for a documentary narration, or keep it in a clear, factual, and explanatory style? The Pulsar Fusion Sunbird represents one of the most ambitious visions for the future of space travel, aiming to completely transform how humanity moves through the solar system. Unlike conventional chemical rockets that burn vast amounts of propellant for relatively short bursts of thrust, the Sunbird is designed as a migratory transfer vehicle, essentially acting as a powerful space tug. Its role would be to dock with spacecraft already in low Earth orbit and then carry them on extended journeys across interplanetary distances, something that has traditionally required years of planning and enormous amounts of fuel. At the heart of the Sunbird is its groundbreaking dual direct fusion drive, or DDFD, a compact linear fusion reactor that makes use of deuterium and helium-3 fuel. This isn't ordinary combustion. It's an aneutron fusion reaction that promises both immense propulsion and a continuous supply of auxiliary electrical power. What makes this engine so revolutionary is its efficiency. With a specific impulse ranging between 10,000 and 15,000 seconds and a power output of around 2 megawatts, it would outperform anything humanity has ever built for deep space missions. The implications of such technology are staggering. Pulsar fusion suggests that this system could slash travel times dramatically, cutting a journey to Mars nearly in half and making it possible to reach Pluto in just 4 years. For perspective, current spacecraft take nearly a decade to make such trips. By combining raw thrust with high-efficiency performance, the Sunbird could unlock a new era of exploration where distant worlds and icy frontiers are no longer unreachable, but part of a realistic roadmap for humanity's future in space. Would you like me to expand this into a slower cinematic version, one that builds more atmosphere and would comfortably run over a minute when narrated? The O'Neill cylinder is one of the most ambitious and visionary concepts ever proposed for humanity's expansion into space. First introduced by physicist Gerard K. O'Neill in the 1970s, this design imagines a pair of enormous, counter-rotating cylinders, each stretching up to 32 kilometers in length and around 8 kilometers in diameter. By rotating, these colossal structures would generate artificial gravity through centrifugal force, creating a livable environment for millions of people. Inside, the habitat would be carefully engineered to replicate Earth-like conditions. Vast strips of fertile land, lakes, and forests would alternate with massive window panels, while enormous mirrors outside the station would direct sunlight inward, simulating natural day and night cycles. The scale of this project is breathtaking, not just as a feat of engineering, but as a new frontier for human civilization. Each cylinder could house up to 10 million inhabitants, offering homes, farmland, and green spaces that would rival the beauty and balance of Earth's own ecosystems. Self-sufficiency is at the heart of the concept. Solar power would provide clean, renewable energy, while advanced systems would recycle air and water. The materials for construction and radiation shielding could be mined directly from the moon or nearby asteroids, reducing reliance on Earth's limited resources. What makes the O'Neill cylinder so remarkable is that it bridges science fiction and practical possibility. It represents not just a dream of living among the stars, but a realistic pathway to large-scale human colonization of space. If ever realized, these giant habitats could serve as the stepping stones that allow our species to thrive far beyond Earth, carrying civilization into the cosmos on a scale once thought unimaginable. Would you like me to make this more cinematic and awe-inspiring, like a narration for a space documentary, or keep it scientific and informative? The Celeste capsule is a stunning blend of luxury, sustainability, and futuristic design, created by Zafalto in collaboration with architect Joseph Durand. Rather than relying on rockets, this unique spacecraft is carried gently into the stratosphere by a massive stratospheric balloon, soaring to an altitude of about 25 kilometers, far above the cruising level of commercial jets. At this height, passengers are able to witness the deep black of space and the curvature of Earth in a way that few have ever experienced. Designed to host 6 guests and 2 pilots, Celeste emphasizes not just the destination, but the journey itself. The capsule is crafted with expansive panoramic windows that allow travelers to take in uninterrupted views of the planet, creating an immersive and awe-inspiring experience. Inside, every detail reflects comfort and serenity. A minimalist interior, a calming palette of creams and soft beiges, and intimate private cabins that provide a sense of both elegance and tranquility. But the experience goes far beyond visuals and design. Guests are treated to Michelin-starred gourmet dining during their flight, making the journey as much about indulgence as exploration. The goal of Celeste is not only to bring passengers closer to space, but also to give them the profound emotional impact known as the overview effect. The life-changing shift in perspective astronauts often describe after seeing Earth from above. By combining eco-friendly balloon technology with cutting-edge design and luxury hospitality, the Celeste capsule offers a transformative voyage where science, art, and emotion meet. It is not just space tourism, it is an extraordinary reimagining of how humans can connect with the cosmos. Do you want me to make this script sound more like a cinematic narration with dramatic pacing, or keep it in a smooth documentary tone?